Hi everyone. In this video, I am going to explain how to write an algorithm and how to do analysis for finding the maximum or largest element in the given array of numbers. Okay, so the given some numbers, some list of numbers. So in that, we need to find maximum number. For that, we will write the algorithm and how to do analysis that we are going to discuss. Assume the given on the 5 elements, an array of 5 elements, 12, 125, 30, 150 and 24. So in that we need to identify maximum. So if I ask you people which is the maximum among these, so everybody, it is very easy, everybody will tell what 150, but we can see and we can tell. But how processor can see? Processor is having any eyes? No. Or CPU or processor system cannot see, but still it has to find that. How it will find? So for that we need to do the procedure, we need to plan that. What I will say, design. First we need to design the algorithm. That means first we need to write the algorithm. After writing the algorithm, then we need to analyze that. Okay, so first let us see what is the procedure. So for the procedure, what I will do, I will assume simply whatever the element is there in the first position, so that it will itself be the maximum. That what I will assume. That means I will assume what? I will assume, I will take one variable called max. So max is equal to what? Max is equal to what? I am using a of 0. That means I don't know what is the number stored in position 0. Whatever the number stored in the position 0, so that element I will consider it as a maximum. That is a of 0. I don't know, in a of 0, 12 is stored or 14 is stored, what number is stored. So simply I will assume a of 0 as maximum element. Okay, so done. So then what I have to do, now whatever I assume that is maximum element is the first element, that is true or false, that we need to verify, check. For that what I will do, I will start comparing this maximum element with the remaining elements. So now I'll compare this maximum element with the next element a of 1. Now what is the condition? Now to check whether whether which element I am comparing. So first a of 1, that means now I'm taking one index. So whenever we are taking an array, we have to take what? One index. So for that I'm taking this as an I. So now I is equal to 1. So a of 1. So a of 1 is greater than max. In this case, yes. So that means a of 1 is greater than the max. That means maximum is not a of 0. Maximum is what? A of 1. So I will change this as a maximum as a of 1. Maximum as a of 1. So next what I have to do, now again, right now among these I checked only first two elements. Okay, first two elements only I checked. So among these first two elements, which is the maximum? A of 1. A of 1 is the maximum. So now I need to check with the remaining elements. So now again I will increment this I to the next position. So now I will compare this maximum element with the next position, that is a of 2. So now maximum is a of 2. A of 2 is greater than maximum. No, whatever my assumption is, that is only right, that is a of 1 is itself maximum. So this is not maximum. So again I will increment the value of what? I will increment the value of I. Now I points to position 3. So then again I will compare what? Maximum value with the next position. So now I am comparing, checking whether a of 3 is greater than maximum. Yes, now a of 3 is greater than maximum. So again I will change what? Maximum as a of 3. A of 3. So now, but again, so one more element is left out in the array. So now I increment I. I'll check the last element, that is position 4. So now I will check whether a of 4 is greater than the max. No. So now I check with all the elements. So now after checking all the elements, what is there in my max? A of 3. That means maximum element is there in the position 3. That is this 150 is the maximum element. So this is what we done. Okay, now we find out the maximum element in the given list of elements. This is what our plan to find the maximum element. Now for this we need to write the algorithm. Okay, now whatever we did now here, the same thing now we are converting into the algorithm. Getting? So now we need to write the algorithm for that. So now I given the name max underscore element for my algorithm. You can give any name. This is just a naming convention, but I'm giving the meaningful name. So since we are finding the maximum element, I took this name. And the parameter to be passed is a of 0 to n minus 1. Okay, that means the given array. So why I take in, so that means we have to write the algorithm, we should work in general. Okay, so that's why I took a of 0 to n minus 1. We are not taking the specific examples. So we know that always array index should start with 0. So we start with 0 and the last element index is n minus 1. Suppose if I have taken say 5 elements I took, last index is 4. Suppose if I take 10 elements, last index is 9. Suppose if I take 100 elements, last index is 99. So similarly, for n element, last index is n minus 1. So I took a of 0 to n minus 1. This is the what? Parameter to be passed for this one. Okay, now what is the first step we did here? What is the first thing what we did? We assume that first element itself is maximum. So I will write, so first element itself is the maximum. That's so I will take one variable max. So a of 0. So this a of 0 itself the maximum element, that what is by assumed. Next what we did, next I'm comparing the next element one by one. I compared a of 1 with max, compared a of 2 with max, I compared a of 3 with max, compared a of 4 with max. Like that I'm comparing my maximum element with all other elements. That means I repeated the same operations. For repeating we have to use loops. So here which loop we have to use? We have to use for loop. Why for loop? Here I know from where to where I need to repeat this comparison operation. Okay, here I started from the position 1 and I ended the comparison operation till the last element position, that is I. See, if you observe, I started I variable from position 1, I ended at 4. Okay, so I need to compare the element from the position 1 to last position n minus 1. So I know how many times exactly I'm repeating. So I'm using for loop. So next is for, then I is running from where to where? 1 to n minus 1. See, I is running from 1 to n minus 1. For that what we have to do, now I need to check if what? If a of I is greater than max, then what we are doing? See, now I checked a of 1 greater than max. If it is true, then what we did? I changed a of 0 to a of 1. Similarly, then I checked a of 2 with a of max. No, it's not right, so I have not changed. So next I checked a of 3 with max. Now a of 3 is greater than the max. I changed again a of 3 as a maximum. So if this is condition is true, if a of I, that is ith element is greater than the max, then you change the maximum value to what? A of I. That's it, the algorithm. End if, okay, end if, and then you end the for loop and then finally return the maximum value. That's it. This is the algorithm. Okay. So hope you people understood. Let us trace this with some example, with this example only. So initially, now this is our array. Initially what? Max is equal to what? A of 0. A of 0 is what? 12. So max is equal to 12. So next, for I is equal to 1. For I is equal to 1. So this is equivalent to 1 less than or equal to 10. So I is in the range n-1 to n-1. True, condition is true, comes inside the for loop. Then you're checking a of I. I value is 1. I value is 1. A of 1. A of 1 is 125. 125 greater than max. Max is what? 12. 125 greater than 12. True, comes inside. A of I. I value is 1. That a of 1 I am assigning to max. That means now maximum is not 12. So this is 125. A of 1. A of 1 is 125. That I am assigning as max. So come out of the if block, goes to the increment part of the ith for loop. Now I becomes 2. Now again check the condition. Again 2 is less than or equal to n minus 1. True, comes inside. Next I am checking a of I. Now I value is what? 2. A of 2. A of 2 is what? 30. 30 greater than max. Max is 125. 30 greater than 125. False. Condition false. It doesn't enter inside the if block. It comes out of the if block, goes to the increment part of the ith for loop. Now I becomes 3. So again control comes to the condition. 3 is in the range n minus 1. True, comes inside. A of I. I value is 3. A of 3. A of 3 is what? 150. 150 greater than max. Yes, 150 greater than 125. Condition true comes inside. Then it will assign A of I value 3. I value 3. So A of 3. A of 3 is what? 150. 150 I'm assigning is max. So that means now maximum is what? 150. So next after that comes out of the if block, goes to the increment part of the ith for loop. Now I becomes 4. Here, what is the number of elements we took? 5. 5 minus 1, 4. So now still it is in the range. 1 to n minus 1 to 4. True comes inside. Now A of 4. A of 4 is what? 24. 24 greater than max, false, comes out of the if block, goes to increment part of the ith for loop. Now I becomes 5. Now it is not in the range 1 to n minus 1. So now condition of the for loop fails. So comes out of the for loop, return max. In the max I am having 150. So thus we find what? Maximum element. Now let us do analysis for this algorithm. Okay. What is the first step for analysis? First step is what the analysis is? Decide the problem size. So we need to decide, that means how many number of elements we are passing. So generally, so in this example we are giving 5 elements, but always we'll give 5 elements. No, sometimes we may give 10 elements, 20 elements, whatever. So in general I'm giving n number of elements. That is the problem size. Okay. So next step is what? We need to identify the basic operation. Here what is the operation we did here? We have not added, subtraction, we not did anything operation. We did only the comparison operation. We only compared the maximum with each element. So this comparison operation here, which is the comparison operation we did here, the ith element is greater than the max, that we did compared. Okay, so this will be the basic operation. Okay, so basic operation is the comparison operation. What is that? A of I greater than max. This is our basic operation. Now third step is what? We need to identify, or we need to decide whether we need to find all the 3 cases or only the average case. So now here the number of times the basic operation is depending only on the problem size. Suppose see here, now in this example, maximum element is the position 150. Assume here the maximum element showed the first position. At that time we need to execute, again we need to check all the elements. Okay, suppose it is there at the last, then also we need to check all the elements. Simply by looking we cannot say. Okay, we need to check all the elements, then only we can say which is maximum. So here, however you give the input, it depends only on the problem size. Hence we need to find only the average case. So what you have to write in the third step, since we need to find since the number of times the basic operation executing depends only on the problem size, we need to find only the average case big theta. Now the fourth step is we need to express how many times this basic operation is executing in terms of summation. Okay, so now whenever your algorithm is having some loops, how many loops you are having, that many number of summation you have to use. That's it. Okay, so now since your comparison is the basic operation, I will take C. Comparison starting character is C, so I am taking C. So okay, C of n, number of times comparison operation executing is equal to, since in our algorithm we are having only one for loop, for I am using one summation formula. So now the summation formula, so now here what is the variable I use in the for loop? I. So I am using, and here I is varying from what to what? 1 to n minus 1. So I is equal to 1 to n minus 1. 1 to n minus 1. Now for each iteration of this for loop, this comparison operation executing how many times? For example here at a time we compared maximum element with the array element how many times? At a time we compared only once. So I will write here 1. I'll write 1 here. Okay. So we know this formula. Okay. So upper limit minus lower limit plus 1. So plus 1 minus 1 get cancelled. I will get n minus 1. Okay. That means we are executing the comparison operation. This comparison operation we are executing exactly n minus 1 number of times. See here, how many times we compared? 1 time, 2 time, 3 time, 4 time. Suppose if you are in 10 elements, 9 tenths. 100 elements, 19 elements. N number of elements, n minus 1. So thus this is the what number of times we execute in the basic operation. But n out of n and minus 1, out of these two terms, most dominating term is what? N. So what I will write? So C, since we are finding only the average case, C of n belongs to big theta of n. So this is our time complexity of this algorithm. Okay. Hope you people understood. Thank you.